צהריים טובים לכולם. שמי אמנון ואני הבעלים והמנכ"ל של טבורית. אני די נרגש, אני חייב לומר לכם, לראות שבעצם הצלחנו בחזון שהתחיל לפני הרבה מאוד שנים של מדענים ואנשי רפואה, להבין שבחבל הטבור יש אוצר בלתי ננאה של תאים שיכולים להציל ולשפר את החיים בצורה דרמטית. זו גם הרבה מאוד גאווה ישראלית, כי אחת החברות המובילות בעולם בתחום, והרופאים שמובילים בעולם בתחום הם גם ישראלים. והתחום הזה הוא חדש, הוא צעיר יחסית גם בעולם כולו. ההשתלה הראשונה של דם טבורי לחולי לוקמיה, שג'ואן אולי תזכיר אותו במילה אחת, הייתה ב-1988 בפריז על ידי פרופסור גלוקמן, אבל החולה היה חולה של דוקטור קורצברג. כמו שאתם יודעים, דם טבורי אפשר גם לתרום לציבור, שזה חשוב מאוד, וגם לשמור למשפחה. אנחנו תומכים בכל החלטה שתהיה של הורים לשמור דם טבורי. המשאב הזה, שיש לנו הזדמנות חד פעמית בחיים לאסוף אותו ולשמור אותו, אסור בשום פנים ואופן שהוא ייזרק לפח. ועל כן חברות ישראליות וחברות ברחבי העולם עושות מאמץ עצום לחנך ולהסביר ולהגיע לכל משפחה שאמורה ללדת, קבלו החלטה לתרום את הדם הטבורי או לזרוק או לשמור אותו לעצמכם למשפחה. תשתדלו שהוא לא יושמד. אבל הכהנת הגדולה של הדם הטבורי בעולם זו דוקטור ג'ואן קורצברג. ג'ואן היא חברת המועצה המדעית של טבורית מזה הרבה שנים, תומכת בנו, היא ציונית נפלאה ויהודייה חמה, שהגיעה לפה לביקור קצר מאוד של 48 שעות במאמץ עילאי שבין כל יתר ההתחייבויות שלה ועשרות ומאות החולים שיש לה בשוטף אצלה בדיוק, עשתה את המאמץ העליון הזה להגיע לפה ל-48 שעות במטרה גם לפגוש אתכם עד כמה שאפשר, גם להעניק לציבור בארץ אפשרות או לפחות תקווה שאנחנו יכולים לעשות את הטיפולים האלה פה בארץ, ועל כן אנחנו במרתון, ממש מרתון של פגישות עם מקבלי ההחלטות על מנת לאפשר את הטיפולים האלה. בכל מקרה, הטיפולים האלה, אם מישהו חסר סבלנות או צריך לקבל אותם מהר וכדומה, יש גם נתיב פתוח היום בדיוק באישור של ה-FDA לקבל את הטיפולים האלה. דוקטור קורצברג תעביר מצגת קצרה על התחום ועל הפעילות שלה ועל מה שהיא עושה והיתרונות של הדם הטבורי. ביקשתי ממנה מאוד לאפשר לכם ההורים לשאול כל שאלה שעולה על דעתכם. כל נושא הבטיחות, כל נושא האפשרויות, כל נושא הסיכון והסיכוי. אל תתביישו, המטרה היא לתת לכם הרגשה שאנחנו איתכם ואנחנו יכולים לתת לכם תשובות. מיקרופונים ימסרו לכם. אנחנו מצלמים את האירוע הזה ברשותכם, כי אנחנו נרצה להעלות אותו לרשתות החברתיות, כי ישנם הורים שלא הצליחו להגיע באמצע היום, וזה חשוב לנו שהציבור יהיה נגיש וידע שהטיפולים האלה. בלי הרבה עיכובים, אני רוצה להציג לכם את דוקטור ג'ואן קורצברג, חברה טובה. The floor is yours.
Hello. Can you hear me okay? Okay. I have to speak in English. Okay. And I'm going to talk with you about the work we're doing at Duke, treating children with cerebral palsy and autism, and a few other conditions with cord blood. But I want this to be an opportunity for you to ask me questions You can raise your hand anytime, especially if you don't understand something I'm talking about, okay? And I'd just like to ask you first a couple of questions. So how many of you have a child who has cerebral palsy? Okay. And how many have a child who has autism? Okay. And anything I didn't mention that, okay. All right. Well, I hope I can give you an idea of what we're doing and what may be coming in the future. How many of you have cord blood stored either from your child or a sibling of your child? Both. Or both? Okay. All right. So you probably know cord blood is the baby's blood left over in the afterbirth or the placenta after the baby's born, and that obviously it can be collected and frozen and stored for future use. And the work that we're doing is taking that cord blood and using it for different medical applications. The first uses of cord blood really started in 1988 with a blood stem cell transplant, or what some people call a bone marrow transplant, using cord blood from a healthy baby sister of the little boy shown in the picture here, whose name is Matthew, who had a genetic disease called Fanconi anemia, which is fatal without a bone marrow transplant. And this child's mom happened to be pregnant when he developed failure of his bone marrow or blood factory. And the baby she was carrying was tested and found to be healthy and also a match to the little boy. And so the cord blood was collected when she was born. And he actually is my patient in North Carolina. And we sent the whole family to France, where this doctor, Elian Gluckman, did a transplant for that disease using the baby sister's cord blood. And it worked. And it's now almost 30 years later. And this is him grown up in a clinic with me. But he is a very important person in part because his blood is made up of all the cells from his baby sister's cord blood. And we know that in a transplant now that cord blood can regrow the bone marrow and the immune system and be durable for at least 3 decades. And we think it will be for his whole life. But he was the first patient to get a cord blood transplant and to demonstrate cord blood had blood stem cells, which could substitute for bone marrow in a transplant. And I'm giving you some of this history so you understand where the story came from. But I also need to say from the beginning that when we treat children with cerebral palsy or autism, we're infusing cord blood in their blood, but we're not doing a transplant. When you have a transplant, you have chemotherapy or radiation therapy, and the intent is to make the cells stay in the person's body forever. And that is what you need to do for cancer or treatment of certain genetic diseases, but it is not what you need to do when you treat cerebral palsy or autism. But I'm just going to show you a little of the history so you know how we got to where we are. So after that first transplant, in the US, there were banks set up for unrelated public donors, and cord blood transplant was used in many different diseases that bone marrow transplant had been used for years. And it was shown that cord blood could substitute for bone marrow in the transplant and regrow the blood in the immune system. And if you look today, there have been 40,000 transplants done that way for children and adults who have cancer or genetic diseases like sickle cell or thalassemia, bone marrow failure, immune deficiency, and for the purpose of today, also metabolic diseases that affect the brain. And in treating those patients with metabolic diseases that affect the brain, we learned a lot about how cord blood can help the brain. I won't go through all of this other than to say that in at least the US, there's licensure for public banks, and public units are available for patients who need a donor for a transplant or an infusion and don't have a donor in their family. So I want to talk about cord blood for a minute. cord blood is stored usually in bags like the one over there that have 2 compartments and also have segments attached, so the segments can be used for testing without disturbing the cord blood itself. By way of disclosure, I run a public bank, so the picture comes from my public bank. But everybody talks about cord blood being a bag of stem cells. And cord blood is not a bag of stem cells. Cord blood is a bag of cells. It can vary from a couple of 100 million cells all the way up to a couple of billion cells, depending on how much is collected when the baby is born. And in those billion cells, let's just use that as a reference point, about maybe 500,000 are true blood stem cells. All right, the rest are all these other cells on this picture. Some are developing blood cells, some are developing immune cells, and about 10% are a kind of cell called a monocyte. And the monocyte in cord blood is unique, and it's the cell that we think is helping patients with CP and autism. And we don't think it's helping because it's engrafting in the brain or turning into neurons or turning into brain cells. We think it's helping because it puts out chemicals that signal cells already in the brain to repair damage, okay? And that's one of the reasons we don't need chemo, because the cells, they're like smart drugs, okay? They're way smarter than drugs because drugs do one thing and cells can do many things. And they can respond to the area of damage and figure out what's needed to help repair that area. So I'm going to come back to that. Now, in the kids with genetic diseases, where we give chemo and donor cells, and we want the donor cells to engraft or stay in that child's body forever, we learned a lot about what cord blood cells can do to help the brain. So this is the little boy with Hurler syndrome. He's 10 years out from a transplant. He would have died when he was about 5 years old if he didn't have the transplant, because that's the nature of that disease. But with the transplant, we studied a bunch of children with Hurler syndrome and showed that their intelligence compared to normal children, so normal children are in the red line with the gray error bars, and Hurler children develop loss of cognitive function, but with transplant, they're able to regain that function and sustain it. So here are 2 of my patients, both the girls, transplanted when they were 1 year old, now going to their prom in high school, which is something in the US, that's a big deal. And now they're both in college. So 1, they wouldn't have been alive. 2, they would have been severely mentally deficient. But 3, with the transplant, they have normal cognitive function and they can go to college. So that told us that cord blood cells were helping the brain to restore cognitive function. That was, in their case, damaged by a disease. These kids have a genetic disease called Krabbe. Krabbe is fatal in the first couple of years of life. Their oldest brother died when he was 2.5. But what's important for you guys to know about Krabbe is that it causes demyelination of the brain. So the covering of the neurons disappears and the neurons die. And there's a genetic reason for that. But again, if we do a transplant, we can stop the process, and the cells from the transplant instruct the cells in the brain to make myelin again and to restore brain function. So these 2 little boys, he was 10 months old when he had his transplant. He was 2 months old when he had his transplant. Here they are 12 years later, and they're both doing well. And their brain did not demyelinate because they got the transplanted cells that corrected their problem. So we know that in certain situations, cord blood can myelinate the brain. And these are 2 other kids with a different form of Krabbe, which is the most aggressive, earliest form. And this little girl who had a transplant when she was 19 days old is normal. And this little girl who had a transplant when she was, I think, 23 days old has trouble walking. And the reason we learned is that in this little girl, what are called corticospinal tracts, the tracts that go from the brain to the legs, was already damaged when she was 2 days old. So the transplant prevented further damage, but it did not repair the damage that was already there. And in this little girl, she didn't have damage when she was born, so she was able to develop normally after the transplant. And I'm just showing you these examples so you get some sense of what we learned that cord blood cells could do. Oops. We also studied the brain of one child with Krabbe who died after transplant. And she died of complications of Krabbe about 10 months later. And she was a girl, and her donor was a boy, and her parents let us study her brain. And we were able to show in her brain that there were male cells all over the brain. So these green dots are Y chromosomes, which indicate male cells. You know, there's X and Y. So the X's are pink and the Y's are green. And you can see there are many cells in her brain that are male, which just proved that after transplant given with chemo, cord blood cells could go to the brain and stay there and engraft. And that's also important for us to know. And when we looked at the kind of cells these are, there's something called microglia, which is an important cell in the brain that mediates inflammation. And I'm not going to talk about this today, but we actually have a cell we grow from cord blood that is this cell, and that we can now give as part of a transplant, hopefully to help the transplant work even better. So that's kind of a background for some of the research we've done in the setting of transplant, where we give chemo, we give cells, we expect the cells to engraft and stay in the child's body forever. Okay. Now, when we knew all these things, we thought, well, maybe using a child's own cord blood without chemotherapy as an infusion in the vein could also help repair injuries to the brain that might have occurred during pregnancy or birth or after birth, but didn't come from a genetic disease. And so back in about 2008, we started studies looking to see if it was safe to infuse children's cord blood through a vein in their arm or their hand or their foot in our clinic. And we did that in a couple of hundred children and published a paper showing that that was safe. There is a 1% or 1 in 100 chance that a child will have a mild allergic reaction when the cells are dripping in, because the cells are stored in a chemical called DMSO, which helps keep them alive in ultra cold conditions. But when it goes in your body, some people can have a mild allergic reaction to it. And that means hives or wheezing. And so 1 out of 100 children who we infused will have that reaction, and it can be treated and managed. And then that led us to continue to explore where cord blood might be useful. And we did some studies in babies with birth asphyxia, like babies who during birth have a problem with low oxygen because of a cord around the neck or a knot in the cord. And we have 2 studies now where we've given those babies their own cord blood back in the first couple of days of life. And we have some evidence that that improves their outcome and helps them have less or no brain damage later on. But we're still studying that, and there's a study in the US in 12 hospitals now that we're doing, hopefully to prove that that works. We know it's safe. We've also done studies in babies with congenital hydrocephalus, which is where you're born with a block of the fluid drainage of the brain, and the brain is compressed against the skull, and that can cause damage. And in babies with something called hypoplastic left heart syndrome, where babies are born with a very severe heart defect and they have to go on bypass or ECMO right after birth in order to have it repaired. And that can cause brain damage, and a cord blood infusion from their own cord blood seems to help prevent some of that damage. And then I'll show you studies we're doing in cerebral palsy and autism. We also know that if our studies are successful and help patients, that some of these patients will not be able to have their own cord blood. Even if their parents wanted to save it, it's possible they were a very premature baby and it couldn't be collected. Or it's possible that there was something called abruption, where the placenta separates and bleeds and you can't get the cord blood. Or the parents may not have thought they would need the cord blood, and didn't collect it. There are many, many reasons. And so we're also exploring whether we can use publicly banked cord blood or donor cord blood from siblings instead of the child's own cord blood for some of these conditions. And we have studies ongoing right now in adults with stroke who are getting unmatched, unrelated cord blood. We finished studies with children with cerebral palsy getting sibling cord blood. And we actually have a study right now in children with autism where some are getting their own cord blood and some are getting an unrelated donor infusion. And we're going to look at the difference to see, one, if they work, and two, if they work, if one is better than the other. So all of this is going on. I don't have time to show you all of it, but I just wanted to give you an overview of what we're doing. So back to my picture of cord blood. When we look at these monocytes in the laboratory, we know that there's a cell called a CD14 cell in cord blood that's special, and that really is the one helping to repair brain damage from low oxygen or what's called hypoxic injury. And we studied this in the laboratory in something called brain slices. And if you look at these pictures, this is a normal brain. Green is neurons, pink is something called astrocytes, and red is something called oligodendrocytes, which tell the astrocytes and oligodendrocytes to make myelin. And if you shock the brain, the neurons die, and you get a big scar, which is all this pink and red stuff. But if you shock the brain and you also put on the cord blood cells, then you don't see the damage, the neurons don't die. And this was really the first hint we got that something in the cord blood cells was preventing damage in tissue where we made an artificial situation, but where we could induce the damage and look and see what could help it. And this is just more of that same experiment, but we took out all the different cells from cord blood and selected them to see which one was really the one helping to prevent the damage. And it came out to be the CD14 cell, not T cells, not B cells, not other cells that are in cord blood. And then we looked at peripheral blood, and if the bars are high here, it means it's not working. And the peripheral blood monocytes did not work. So again, it's something about cord blood, and it's different than bone marrow. It's different than adult blood. I don't know if you guys have ever asked me, but I get a lot of questions from people who may or may not have their child's cord blood saying, can't we use bone marrow from my child? But in the work that we have, these particular cells that we think are doing the job only come from cord blood. They do not exist in the bone marrow. They do not exist in the blood, okay? So it's something unique about cord blood that can do this, and we're taking advantage of that for people who have their own cord blood, and then for kids who don't, either from using cord blood from a sibling or an unrelated donor. But the part about using cord blood is important. So with a lot of background work, we did a trial in children with cerebral palsy, looking at whether infusions of their own cord blood could help improve motor function. And we published this study a couple of months ago, and you can look for it in a journal called Stem Cells Translational Medicine. I'm just going to show you some excerpts. But there were 63 children on the study. They were between 1 and 6 years of age. Their cord bloods came from 16 different banks around the world, including a few from here. The kids had to have CP with spasticity because the test we used to see if they had improved motor function, which is called the GM-FM or Gross Motor Functions Scale, depends on spasticity. And I'll show you how we designed the child in the next couple of slides. So children and their cord blood units were screened, and if it looked like they were eligible for the study and the cord blood unit had to meet specifications I'll show you in a minute, they came to Duke for a qualifying visit, and that was on a Monday. And if everything checked out and they were checked by a neurologist and a developmental pediatrician, they were enrolled on the study and randomized. And on Tuesday, the children came to the clinic and got either a cord blood infusion or an infusion of placebo, which is fake stuff. It was pink tissue culture media that had the same freezing preservative called DMSO, so everybody got pink stuff, and the DMSO makes your breath smell. So everybody's breath smelled. And nobody knew, except the lab who mixed it up, who got what. And during that same week, the children also had an MRI and testing by a physical therapist and testing by a speech therapist, occupational therapist, and a neuropsychologist. Then the kids went home, did all the things they'd been doing for their regular supportive care, and came back a year later. They repeated all the tests, and they got a second infusion, and the second infusion was whatever they didn't get the first time. Again, nobody knew the order, but if kids got cord blood the first time, they got the placebo the second time, and if they got placebo the first time, they got cord blood the second time. And then everybody came back a year after that, and all the studies were done again, but there was no more infusion. You might ask me, why did we do 2 infusions? It was because parents told us they wouldn't put their kids on the study if they didn't know that sometime during the study their child was actually getting cord blood. But for us, we needed mostly to look at this first visit to see if we saw an effect of the cord blood, because that's the way these studies work. So does anybody have any questions about that? We good? Yeah. I can't hear, sorry. Oh no, I have coffee. I just have been I've been on too many airplanes and giving too many talks, so I sound hoarse. I'm okay. Thank you, though. Okay, so one of the... Oh, sorry, yeah. Oh, you can just yell.
Would it be beneficial to give a second infusion, not the placebo, just giving them the cord cells two times?
So that's a different question that we didn't ask in this study, but we did look at in a couple of the other studies I showed you, and we do think it's beneficial to give more than 1 infusion if there are enough cells in the cord blood. So one of the things I didn't show you yet is from this study we learned that the dose we give is very important, and that if you don't give enough, you don't get an effect. So it's common to not have enough to give more than 1 dose, unless it happens to be a very small child with a great collection. So yes, it would be, but we didn't study that in this study. And studies don't always make sense to people looking at them from the outside, but if we don't do the right study that can show a difference, then the regulators in the US, it's the FDA, and the insurance companies will not pay for the therapy or approve the therapy. So we have to sometimes make rules about the study that seem very strict in order to get progress so we can make therapy available to more patients. So the other thing that was hard for some families was that we had rules about the cord blood and what it had to have in order to be used in the child on the study. And it had to have at least 10 million cells per kilogram of the kid's body weight at the time the child was going to be infused. It had to have viable cells. That means living cells. That makes sense. You don't want to give dead cells to a child. It won't hurt, but it won't do anything. It couldn't have contamination with bacteria or fungus. That's very dangerous. It's a big frustration to a lot of families because sometimes when cord blood is collected, it gets contaminated. If you think about birth is not a very clean process. So in order to collect cord blood well, the obstetrician or the midwife or who's ever collecting really has to do a good job cleaning the cord, and that doesn't always happen that way. But we could not put a bacteria back in a child's blood. That's too dangerous. We had to confirm that it was that child's cord blood, and we did that by testing one of those segments and also testing the child's blood or smear of their cheek, called a buccal smear, for something called HLA, which is tissue typing. We had to know the mom was tested for HIV and hepatitis B and C and a couple of other diseases that are known to be transmitted through the blood and are normally screened as routine screening for blood transfusion. And then we washed all the cord blood units on a machine in our lab to get out most of the chemical, the DMSO, and we gave it through a peripheral IV after 1 dose of Benadryl and prednisone-like medicine called Solumedrol to prevent reactions. So that was all part of our protocol, and I'm a transplanter. I've done this for a long time, and I really believe those things make it safe to give the cord blood in the clinic as opposed to in the hospital. And here's the scale we used, the GMFM, to assess response. So this is also important to understand. All kids with CP gain some function naturally. And in order to prove the cord blood cells were doing something, we had to show that the kids gained more than they would have by what we call natural history, all right? So this happens to be a scale that was developed and published in 2002 for kids with CP that shows their natural progression of gain of function without any therapy. And kids are assigned a level based on if they're mild or severe from 1 to 5. And then by level, you can see by age how many points they should gain each year. And if you look, this is that same graph. If you look at kids, say, who are in level 2, which is mild, between the ages of 2 and 3, they're supposed to gain about 12 points. So if I put a kid in the study and they're 2 years old and they're level 2 and they gain 12 points by the time they're 3, they didn't respond to the therapy. They just did what they would have done naturally. So we had to, but on the other hand, if I take a more severe kid who's older, they may only naturally gain 1 point. So what we had to do was figure out a way to say what was a significant change. And we said that the child had to have 30% improvement of function above where they should have been by age and level, okay, in order to say they definitely got better from the cord blood. And that's a pretty strict bar, but again, we're dealing with regulators and payers, and we have to prove this. We can't say, well, maybe it worked or not. We have to say it definitely worked. So here's the results. So when we just looked at the raw score in all the kids, this is blue is placebo and red is treated. At 1 year, they all went up. And that's okay because all the kids, if you go back to the score, they all go up, right? But if we looked at the change score, which is that 30% difference, then we saw that the kids, and they're in green here, who got higher doses, and the dose happened to be 25 million cells per kilogram, which is the same dose that works in leukemia and transplant. Those kids had a statistically significant improvement above and beyond what would have been predicted by the score for their age and level. Yeah?
Can you say about the dosage related to the weight of the child, the age?
Mm-hmm.
Until what age of the child is it efficient to use the
So it depends on how many cells were collected and how big the child is. So if 2 billion cells were collected, it's going to work for any age and size.
Sorry?
So it depends on the age and the size of the child compared to how much cord blood was collected. So when it's collected and it goes to the bank counts the cells and they give you a number. It can be 200 million, it can be 1 billion, it can be any number. So you have to take the number collected divided by the child's weight and see if you have enough. Yeah. Oh, okay. You can come. Okay.
So let's just assume in some miracle way that my child can do this.
Right.
When will I know that the little bit of blood I saved for him will be available to him? Is it safe? Is it clean? What kind of process do I need to do so I know that he can actually get that bit of blood?
Well, so first, when it is first collected, when you have the baby, it's collected at the delivery, and it goes to the bank. The bank counts it and freezes it, usually within a couple of days. And so they know the cell count right away, within a few hours or so. And then the sterility testing takes 2 weeks. At least in the US, we have to do it for 2 weeks. That's the culture to say there's no bacteria or fungus in the cord blood. It's done by the bank when they get the cord blood, before they freeze it, okay? The tests on mom, because you also give your blood, take about a week or so to come back. So that information is... Yeah, but it's still, yeah. The way the U.S. works, it has to be done within a week of the birth of the baby, even if you had it before. And then, I'm sorry, the identity is checked later, but the number of cells and the sterility is known at the beginning. Yeah.
רק הערה אחת קטנה, אנחנו בטבורית עוקבים אחר כל התקנות המחמירות ביותר, כך שמה שעושים, אנחנו עושים גם כן מבחינת הבדיקות והספירה של התאים וכו'.
I can't understand a word you're saying. Sorry. Yeah.
Yes, my child have a CP, and we're waiting now since we met 3 years ago. We believe the stories, it all seems fine, and we believe it worked. But in the reality, he didn't get it. 3 years, and in 24 of January, he's 7 years old.
Mm-hmm. What does he have?
CP.
Okay.
And we're still waiting and for papers and...
Well, so I'm going to get to that, but the studies only allow so many children, all right? And so if the studies were full, we couldn't treat more children until we proved to the US FDA it was safe and that it had some benefit. So this, which we published 2 months ago, yeah. Wait. Can you give me 5 minutes, okay?
חבר'ה, תנו לה לסיים, היא תגיע לדברים האלה, בסוף נעשה שאלות, אחרת אנחנו לא נצא מזה בבקשה, ויש לה כמה הפתעות טובות בסוף, אז כדאי לשמוע.
Yeah. So here, this shows the high dose worked. Same thing here. This is a different motor scale called P-Buddy. Also showed the high dose worked. And then we looked at all the kids 1 year after treatment to look again at the dose and showed the high dose worked. The low dose didn't. And these is the GMFM and the P-Buddy. And then we looked at MRI and we showed the reason it's working is because the kids who got better made new connections in the brain. All right, so red lines mean new connections. Blue dots like this, turquoise, mean bigger nodes. These are like airport hubs. In your brain, you have these nodes like New York, and then how many planes fly to New York to Chicago is a lot, but New York to Raleigh-Durham, where I am, is a little. But if you strengthen the pathway from New York to Raleigh-Durham, that's a good thing, and you get more function. So this is a statistical way to look at that in all the children. And it showed that the way this is working is they built new connections in the brain. And we know those CD14 cells promote the brain to build these new connections because of work we've done before. Yeah. For autism, yes, I'm going to show you that in a minute. So here's a little boy who, I hope this will work, yeah, who is filmed before he goes on the study, and he has braces, he scissors like this, his legs, and he can't walk alone, and here he is a year later. So he can walk alone, no braces. So this kind of response is what we scored as positive and above and beyond what you would predict for a child who starts like this 1 year later. And I am not a physical therapist, I am not a neurologist, so I didn't do this. My neurologist and physical therapist did this work, which is better because if I just say it, they won't believe me. So they were the ones who scored this, yeah.
Hi. So I have 2 kids. We took cord bloods with Taborit for both of them. My youngest is having a genetical condition. Okay, it's a CP-like. All the doctors say that it's a CP-like.
Right.
We have here neurologists. I don't want to say names, but we are also with follow-ups in this hospital and also back home. We really want to do this kind of, let's say, donation, so maybe it will help my child to progress. It's very similar to the cases that you show here. Do you know how, I mean, do I need to do it only with research and experiments, or can I just do it as a regular process or something like that?
There is no way in the US or in Israel, which have regulation, to do it as a regular process yet.
Okay.
And in genetic disease, the reason for CP may be different. So none of the children on any of our studies for autism or CP had known genetic conditions. Because for the genetic conditions, for cells to help, just like I showed you at the very beginning, you have to give chemo and get the cells to stay in the brain. And so we have not tried that in kids with CP or autism because the procedure with chemo has a risk of mortality. 1 in 10 children can die from the chemo. So CP and autism so far have not been considered, serious enough. I know they're serious, don't get me wrong, but serious enough to take that kind of risk.
So you say since this is involving chemo,
Well,
it's more complex and you don't want to try it yet?
it's risky. Your child could die from the chemo.
So it hasn't been
It has not been done. No.
Okay.
And everything with the regulations has to be slow and steady. So the regulators would not approve chemo for a child with CP or autism.
But it's not. It's a genetical condition.
Right.
I mean, when they scanned his brain, it was perfect.
Right.
No
Okay.
malfunctions there. So you say that for this case, only chemo, and then to have the donation.
I'm saying that just giving an infusion of cells, of his own cells, would give him no benefit.
That's why I said that also
Okay.
his sister
But
has,
someone else's cells, maybe, but it isn't known, and it hasn't been tested. And from what we know of genetic disease, just an infusion probably will not correct the problem.
Okay.
Okay, so we can talk more after, but let me get to the other part, and
Okay.
then I'm happy to answer more questions. We also did test sibling cord blood in kids with CP, if it matched halfway or all the way, which is 3/4 of siblings. So 3 out of 4 siblings will match half or full. And we did those infusions and showed the same thing. We showed it was safe and that the GMFM went up, just like in the kids in the study for the autologous infusion, as long as we gave the high dose. And so that enabled us to do certain things. One is we're having a meeting with the FDA to see if they'll approve this for autologous and sibling cord blood without further testing. Their chances are 50-50, honestly. I don't know, but we'll know in a few months. Few months. But in the meantime, we opened something called an expanded access study, which they let us do, and I'll show you after I talk about autism, which allows us to treat kids with CP and autism with their own cord blood or sibling cord blood as a standard of care. So it means the care is charged. It's not paid for by a study, but the infusions can be done, all right? And we hope that it won't be only at Duke that something like that can happen, but at least at Duke for right now, we've just gotten that approved. Now let me show you the autism data and then we'll talk. So we published a study in kids with autism where we gave them infusions of their own cord blood for safety. And I will say, I treat a lot of children in my life. For the children with autism, we had to change the way we helped them come to the hospital and the way we did their infusion because they hated the hospital. They hated having monitors, something on their finger, taking Tylenol, let alone going in an MRI scan that does banging. So we had to sedate all the children to have the MRI and have the infusion. so that we could get it done and they weren't upset. Okay, for CP, it didn't have to be that way. So we learned a lot about how do we help a child with autism have this kind of treatment. But the theory here is that in autism, there's an abnormality called neuroinflammation, where a kind of cell in the brain called the microglia is activated. And when babies are born with autism, they don't control which pathways turn on and off the way a baby without autism does. So some pathways that are supposed to shut down in early infancy don't. So babies are born with all the pathways on. Remember that picture I showed you with the lines? It looks like a Smurf doll. You know what a Smurf doll is? With all the lines. So in normal development, those pathways turn off, and only the ones that are needed to progress for motor function, cognitive function, hearing, speech, stay on. But in kids with autism, more pathways stay on than should, and that's called microglial activation. And when they stay on, children are hypersensitive. They have trouble filtering sensory input and visual input, sometimes hearing input, and it leads to many of the problems that you see in the behavior of children with autism. So the theory was the cells would calm that down, and we know from work we do in the lab that the CD14 cells calm that down. Okay, so it was the same kind of theory using the 14 cells, but for a different reason. And we did this trial. Everybody got treated. We looked to see if it was safe, and we looked to see what tests we could do in a what's called phase 2 trial to prove that this might work. So we had 25 kids. Median age was 4.5. More males than females, because autism is more common in males. The kids had nonverbal IQs that ranged from 35, which is very low, to 123, which is high. But the median was 64. And this is just descriptive of the kids. And as far as the infusions go, the kids did well. 3 kids had mild allergic reactions that were treated with Benadryl, and they finished their cells. And there was nothing that said we couldn't go to the next level of study. But we also looked to see how kids did after this infusion. And remember, everyone was infused. And we looked at a test called the Vineland Social Behavior Scale, which is a test commonly used in assessing the behavior of children with autism. And we were able to show that at 6 months, the kids improved more than they would have been expected, and that it was sustained at 12 months. And that was just after 1 infusion of cord blood. And we were also able to show that the kids who had the bigger response in red were the kids who had the nonverbal IQ of 70 or above, so the kids with a little bit higher function. The kids with lower function stayed stable, which is actually better than would have happened by natural history, where they would have gone down, but they were not as good or didn't have as dramatic a response as the kids with the higher nonverbal IQ. We also showed that a variety of different tests that are done by the autism specialists, one called PDDBI, one called CGI. These are all behavioral rating, and then the expressive vocabulary of these kids from baseline to 6 months improved. That eye gaze improved. I know these are kind of complicated pictures, but the kids who had improvement in eye gaze, which is measured on an iPad where you show pictures of a person and then these inanimate objects, and you can measure the time the child looks at the person's face versus the toys. And autistic kids will look more at the toys than the person, and kids without autism will look more at the person than the toys. And it's a surrogate test, but that improved. And we looked at MRI, and we saw new tracks in the visual area, the voluntary movement area, and the speech area. All of this is being pursued in a next study, but here's an example. So here's a kid who's nonverbal. So the examiner, we're looking at the back of the kid and the front of the kid.
My turn? Thank you.
And she's asking him to name the pictures.
What is that?
And he isn't going to do it. And he doesn't talk with her.
That's a dog? Can you say dog?
So you can see he's really not engaging and he's not talking. And there I'm going to show you the same child 1 year later after treatment.
Ready?
Yes.
What is that?
The banana.
Cooper, each of those. What is that?
So he's saying it's an airplane.
Goes down, down, down. There goes.
Yeah. That's an airplane.
Then it goes. And it goes up.
Oops, sorry. So you get the idea. And this child, so we had many children improve like this. Now they're all getting other therapies. They all got cord blood. Their IQ improved partially because of testing. When you speak, you can test better. But there were dramatic improvements like this. And it was enough for us to say we should do a phase 2 study. Now I know a lot of you would say, why isn't this enough? But the regulators will not say this is enough. We have to do a placebo-controlled study to prove that. Autism. Yeah. So now we're just finishing, by the summer, a study with almost 200 children who got, with autism, who got randomized to get either placebo or cord blood. And the kids who got cord blood, half of them got their own, and half got an unrelated donor, based on who had which. And at the end of this study, we will know if cells work, and we will also know if cells work, do your own work the same or less better or more better than a donor. So this is a really important study because it will help us do more things in CP as well as autism, because it's testing whether your own works better than a donor as well as whether cells work better than a placebo. So this study will finish in August and will be analyzed a few months after that. And by next fall, we'll have the answers. And it will be very important for whatever the next steps we do are. Yeah. Oh, sorry. Now, because, yeah.
I read the article.
Sorry. Yeah.
Okay. I understand it's safe, but just like you said, in the CP research, a natural improvement is expected. So you had to define a large, another 30% improvement.
Right.
But in this experiment, you didn't have a control.
Right, because this was phase 1, and now we're doing that in this study that's ongoing. So so I don't have those answers, but I can't show it to you, but the NIH in the US has done a natural history study on kids with autism. So we know what they should do on their own. And in fact, as children get older, they tend to get worse. So we have those curves to compare for this study, but I can't show it to you because they haven't published it yet. And also in this study, all the children got the dose we found was active in CP. So nobody got a low dose. Everybody had to have enough cells to get a high dose because we believe that that dose is important. So the children on this study only got the higher dose. But you're right, but we have it. We just don't have that analyzed yet. So this picture is like the CP study, but it's just not finished yet.
Excuse me?
Yeah, sorry.
I would like to get back to the child with the autism, the example.
Yeah.
You saw it at the beginning and then 1 year after. Mm-hmm. How do you know that because of the 1 year period that he got, for example, behavior therapist, that the improvement is not coming from the behavior therapist?
Well, yeah, so first of all the children did get therapy. We maximized ABA and whatever else they were eligible for. And we don't 100% know, except from these natural history curves. We know that a child who was nonverbal at the first year would be very unlikely to catch up that much or get a 20% gain in IQ by 1 year.
But it can also be because of the child maturity.
That's why we have to do the controlled study. That's why we're doing this. So you're right. Yeah.
Okay. I have a small question regarding the phase 2 that you are. I have a second regarding the phase 2.
Yeah.
According to my knowledge, something similar to your clinical test, phase 2, a group against a placebo, was conducted in Shatter Institute in Sacramento by Dr. Michael Ches. If you know his work, because...
Oh, I know that work, yes.
Because his conclusion was that these treatments work for autism.
No. Okay. I reviewed that paper. I'm an editor on that journal. I know the final version of that paper, which is not published yet, is coming out. Okay.
I saw the YouTube clip that the movie that he's
telling you.
Okay.
Okay. He did not have enough data to say it worked or not.
Yeah, it was a very small group.
He did not have statistical significance to his endpoint.
Okay.
He played around with how he mixed up the kids in groups, and he still didn't get statistical significance. So there is a trend similar to what we saw that maybe it's beneficial, but that study does not prove it's beneficial.
Okay.
And I know.
Okay, another small question, if I may. I know that some institute in Panama and Thailand and even in India, they are performing some kind of stem cells treatment. I'm not sure whether it's cord blood or something else. And they report, like what you said, that it affects the...
Yeah, so I don't know everything that every group is doing, but the group in Panama is using what they call an MSC, which is a cell from cord tissue, actually. But they make it, they say, from cord blood, which you can't do.
Okay.
And they are infusing just random cord blood to kids with autism, and they are saying it works. And I'm not disputing that, but they haven't done any kind of trial. They just take your money and infuse your child, and if it works, that's good for you.
You believe it's not as effective as the on-cord blood
so
or the similar?
I don't know. So I didn't put those slides in, but we are making MSCs from cord tissue. We are testing them in children with autism. They have an advantage of being able to be given more than one time. Mm-hmm. Somebody asked me that at the beginning. And you can give from the same donor multiple doses. So we are testing that in kids with autism, but we are manufacturing it in a safe way where we know the cells are reliable and will perform, and if they're going to have benefit, they will. So I think in the next few years there'll be answers. I don't know what they're doing in India. There's some stuff in Mexico, there's some stuff in Korea. The one thing I would say is don't let anybody give your kids cells you don't know what they are. Don't let anybody give cells where you don't know that the donor was tested for hepatitis, HIV, because your kid could get hepatitis or HIV. And don't let anybody put cells in your kid's brain or spinal fluid that you don't know were purified, because that can cause tumors, death, really bad things. And I know you want to help your kids, but if I were you, but I knew what I know as me, I would not do those things. And there are very scary reports out there of bad things happening because people didn't manufacture the cells right. They didn't collect them right or make them right or test the donor or keep them sterile. And then your child can end up with being much worse than they are now.
Okay, thank you.
I'm sorry. We are... What?
Really, in our case, there's no enough time to make it because...
One second.
Well,
Slicha. Let's do it.
Let me show you
Joanne,
the last part. So
Joanne, we have 10 minutes.
Okay.
So, 2, 3.
I understand, and I
Really, I was looking for any kind of doctor to do it, and it might be risky.
So,
What is our option?
so we just opened. Wait, we just opened.
6 years after this research,
I know.
since he was 3 months.
Yeah. I know. I can only do what I can do. I stand on street corners raising money to do this, okay? And I, in the U.S., can't do this, and you in Israel, your doctors can't do it without the regulator's saying it's safe. I know they're slow and they take too long. But can I just say, we now opened something called expanded access. So at least for kids who have their own cells or sibling cells that are sterile, and there's enough dose, they can be treated at Duke. And someday, we hope to work with people and the doctors here to do the same thing, where they can come and get an infusion, all right? And if our tissue cells or the donor cells that I showed you in the autism study are safe and effective, then this can be expanded to include those cells. That's in next summer, next fall. But kids come, they get treated, we report the results. So this is for kids with CP, autism, HIE, stroke, hydrocephalus, apraxia, or similar injuries, like a child who might have had near drowning is a hypoxic injury. Huh?
תנו לי להסביר בעברית שכולם יבינו. One point, let me translate it to Hebrew because it's a very important point.
Okay, but they can also go to the website, clinicaltrials.gov in the US, and it's a website, and it lists all the trials, and you say autism, you look for Duke, and it tells you all this, okay?
תנו לי רגע להסביר לכם בעברית פשוטה מה ההישג הגדול שג'ואן הצליחה להשיג. ה-FDA שוכנע שהטיפול בדם טבורי עצמי של הילד עצמו או של בן משפחה בנזקים מוחיים, כלומר אוטיזם ושיתוק מוחין, הם בטוחים. עכשיו, מותר להם לגבות כסף על זה, הרי בניסוי קליני אסור לגבות כסף. בניסוי קליני לא כל אחד יכול להיכנס אליו, בגלל משקל, בגלל גודל, בגלל גיל, בגלל כמות תאים. ה-FDA נתן דרך מהירה נקרא לזה, נתן אפשרות, פתח, להורים עם ילדים שסובלים מאותן מחלות, לקבל את הטיפול הזה בדיוק בקליניקה של דוקטור קורצברג. זה כרוך בתשלום של $15,000 פחות או יותר, זה כרוך בטיסה, זה לא פשוט עם ילד במצב כזה לטוס, אבל האפשרות היא מיידית. אנחנו בטבורים נספק לכם את האימייל של המרפאה שלה, של האנשים, יש לה צוות שמוכן לקבל את הפניות שלכם. מספר ילדים ישראלים כבר קיבלו את הטיפול הזה, נוסעים לשם, זה ללא אשפוז, זה טיפול אמבולטורי, זה טיפול של יום. נותנים את המנה של התינוק עצמו או של אחד האחים לילד. לא צריכים לעבור אחרי זה פלציבו, כי אנחנו לא במסגרת של ניסוי קליני, לכן לא צריכים לעשות השוואה, וטסים חזרה לארץ אחרי 48 שעות, פשוט בהשגחה לראות שלא נגרם שום נזק. הדבר הזה הוא חשוב ביותר. המטרה שלנו, וזה מה שאנחנו הבאנו במאמץ רב את דוקטור קורצברג לארץ, ולשכנע גם את הרשויות הישראליות לאפשר את הטיפול הזה פה בארץ. חבר'ה, זה לוקח זמן. משרד הבריאות, הרופאים, אנחנו הצלחנו לגייס אתמול במרתון של דיונים הרבה מאוד גורמים שיכולים לדבר הזה לקרות פה בארץ. לא פשוט לכם כהורים לקחת ילד אוטיסט או עם שיתוק מוחין ולטוס איתו 14 שעות לארצות הברית, זה ברור לכולם. אנחנו מנסים לשכנע את השלטונות הישראלים בתהליך שלא קורה בין לילה, לאפשר לכם ההורים לקבל את הטיפול הזה פה בארץ. כן, כן, בבקשה.
I have a question about safety. I'm the mother of a 3-year-old on the spectrum, and I really only have one question. I know that the FDA says that have approved that there is no danger.
Right.
How do you know that there really is no danger? I know that there's 2 genes. I'm a mother, I'm not a doctor. I know that there's 2 genes that are associated with autism, and children that have those 2 genes are not accepted into your study. Right. What about if there's hundreds or thousands of other genes that have to do with autism that haven't been found yet? What if, and this is my logic as a mother, what if I'm giving my son more of the same of something that we haven't even found yet? That's my biggest and actually only worry with all of this. Because if there was no danger, even if there was no improvement, I would do it, just in case. That's my question.
Right. So we have no evidence there's any danger of giving autologous cells. We have 40,000 children who receive donor cells for leukemia and other conditions who have not had tumors or bad things happen. So we think giving a cord blood infusion in general is safe. Can I prove it to you forever for the next 100 years? No, we need the next 100 years to happen. But from everything we know, it looks safe. And the risk of giving your own with a genetic disease is just that it won't help. Not that it will do something bad. But the risk of giving a donor, particularly not a sibling, could be that it sensitizes your child against a donor because it's not theirs, and then it could cause immune reactions. So we are screening for that on all these studies we're doing. So far, we have not seen signs of that, but that's why we have to have that follow-up data to know for sure. So your own should be safe, but if you have a genetic condition, it's going to have the same condition, and it's not going to have the power, so to speak, to help. Okay? Yeah.
I have a question.
Yeah.
How do you get, you say that the CD14s are the ones responsible for CP improvement and that you give it in with peripheral blood infusion?
With cord blood, yeah.
How do you target them to go into the cell, into the brain?
We don't. They do it. They are smarter than we are. I mean, we don't have a way to target them to get into the brain.
So basically you trust the circulation to do the job?
We know they put out chemicals that go to the brain. We do not think the cells themselves have to get to the brain, okay?
Thanks.
But we don't have a way to track them and know where they go.
Maybe my question might be naive in some sense, but when you talk about a dose, how much of the cord blood is used? And another question, can you somehow replicate the cells that you know are effective?
So the amount of cord blood that's used depends on the amount collected in relation to the size of the child. So the amount collected is just what happens at birth. It's related to how big the baby is and how much time the obstetrician takes to collect. And sometimes they can't get enough. I mean, it varies. But what they get is what they get. There's a number of cells counted in whatever they get. So that's the dose. And then how much you use is based on the weight of the child at the time they're going to receive that dose. So you have 200 million cells and your child weighs 10 kilograms, then you have enough basically for one dose of 20 million per kilo. And I said we want 25 million per kilo. If you have 500 million cells and your child weighs 10 kilos, you have one dose of 50 million cells per kilo. So it's all dependent on what was collected and how big your child is at the time of the infusion.
Just to continue, two things. So what you're saying is that A, you need to do the therapy earlier as possible because the child will gain weight. The second question
it depends how many cells you have. Yeah.
The child would grow. But,
Right.
but going back to my second question is, can you synthesize the cells from the cord blood?
So no, you can't synthesize them, but there is one company in Israel named Gamida Cell, which is a great company in Jerusalem, where they can expand the blood stem cells. Remember I showed you the picture at the beginning with the cells at the top? Those are the ones used in a transplant. Those can be expanded. But the CD14 cells, so far, cannot be expanded. We're working on ways to try to do that. But right now, no. Yeah. Oh.
Hi, I have a question, a general one. Is there any experience with treating epilepsy? As epilepsy, we know it's a piece or part of CP. Is there any experience with that?
We haven't had any direct studies in epilepsy, but in our hydrocephalus study, many of the children had epilepsy as part of the hydrocephalus. And although cord blood helped many things, it did not help the epilepsy. It did not reduce seizures. Also in the kids with the metabolic diseases who get the transplant, it does not reduce seizures. Oh.
Sorry, I have a technical question. Do you do any technical procedure like cell sorting or something else before you transplant the cells to the children?
So right now, no, we thaw them and wash them and give them with no further manipulation.
The native pool without any procedure in vitro.
Well, correct. There are, in transplant, many procedures done, but those are very complicated from the regulatory point of view. So we would only do that if it improved the product. So if we could expand, whoever just asked me, the cells, then we would do that. But the pathway to get that to patients is more complicated, takes longer, it's more expensive, more tests have to be done. So we aren't doing that for this.
But you can characterize
Yes.
cells before you done the procedure?
So we count them, we characterize them by flow cytometry. We know the number of different types of cells going in. We grow colonies.
But probably CD14 positive cells you can't check.
We can count them. Okay. Yeah, but we're not we haven't figured out a way to expand them. And when I say we, I don't mean just me. I mean many researchers working on this.
Okay. Thank you.
Hi. Can you refer to the age of the child? If I have a 12 years old, and we have his cord blood, and also his twin brother cord blood, and also the severity of on the spectrum.
So this is for autism?
For autism.
Yeah, so our studies in autism started with kids up to 6. And then in the next trial, which I didn't have time to show you, we went to, well, the one that's going on now, it's to 8. And in the MSC trial, it's to 12. So we'll have information, and I don't know right now if it matters. I think younger probably is better, but we don't really know. In CP, in the first study, which was 1 to 6, we didn't see a difference in age or in severity of CP related to response. But that's a very young cohort. So with the expanded access, where it's up to age 18, we'll get more information. But right now, I don't know.
Okay, thank you.
Excuse me, I have a question here regarding the safetiness of this autologous cord blood. You say that it is safe. According to one of our neurologists, she said that there might be some mutation that the stem cells of the cord blood or the cells themselves, they have a chance to go under some kind of mutation and develop some kind of cancer or tumors. Maybe it's a lack of her knowledge because she's not a hematologist, but just to hear from you, what do you think about that?
I don't think there's a risk of that when the cells are just, they're stored at birth. They're thaw, and they're infused. But no, I think there is not a risk of that, and there's enough data to be sure of that. But if the cells are expanded, then they may develop a sort of tendency to turn into cancer cells. So if you expand cells, there are other tests you have to do to figure out that that didn't happen. Those tests exist and can be done, but it makes the manufacturing more complicated. But the simple, take your child's cord blood, store it, then thaw it, wash it, infuse it, does not carry a risk of mutation in the cord blood cells.
Okay, so for the simple process, the autologous cord blood transplant or infusion, there are no risks even for mutation.
That's correct.
Another question regarding the phase 2, or you are conducting the ASD infusion. According to what I read, also in phase 1 and phase 2, about 2/3 of the children are improved.
Right.
And there are 1/3 which are not improving. Do you have any idea why those 30%, maybe is it because of their age, the amount of the stem cells in the cord blood? Is it according to the severity of the ASD?
So in our work, in phase 1, where all the children got treated, 70% improved.
Something
and
like
the 30% who didn't improve were likely to have a lower nonverbal IQ. That's all we knew. That's all we know right now. So that was, I showed you that picture second here. So the kids who stayed stable, this is one test we do, were the kids with the lower functioning, which was lower IQ, below 70. Okay?
Only one last 2 questions, please. One over there with the guy and another one because we have to leave. Okay?
Sorry.
Hi, doctor.
Yeah.
This is the second time that I'm coming to meet you. I just have one question. If you have any prediction about when you're going to do some research about adult with CP. I'm an adult with a CP, and I have cord blood from my daughter, which is okay.
Yeah. So cord blood from your daughter will be a half match. That's the good news.
Yeah, I know.
But you know, the oldest patients we've treated are about 13 or 14 at this point.
Okay, I am 41.
Yeah, I don't know when. I hope soon. I just don't know yet.
So I just need to keep following your work.
Yeah, keep calling me.
Okay, I will keep following. Thank you.
Hi. So I guess it's the last question. Good afternoon. Thanks a lot. Very interesting. I just have one question concerning a little girl that you were talking about sooner. I think she had the disease of Krabbe, and she died after 10 months, according to what you said. My question is that, is there any known side effects due to the fact that the donor was a boy and she was a little girl? And is there, like, in more general point of view, is there a, I would say, is it preferable to use, for a little girl, for example, is it preferable to use cord blood from her brother or from a female donor?
As far as we know, there's no effect of sex differences in infusion or in transplant. So there's not a preference for the sex of the donor being the same as the sex of the recipient.
All right, but those cells that you showed
Right.
afterwards in her brain, the green ones were male ones.
Right.
It doesn't affect anything basically on the behavior of the child.
No,
Right.
and this has been done not only with cord blood but with bone marrow in several 100,000 patients over the last 30 years, and there's no effect on gender expression, hormones, any of that.
All right. So in general, it's better every time to go for siblings instead of donors, or like.
We don't know. I can't answer. I don't know.
All right.
Yeah.
Thank you very much.
You're welcome. Last one.
You said that there's going to be or probably going to be a clinical trial with donors for CP donor.
Right. Yeah.
So any updates on that? Because we are following your team for more than a year already, and we know that.
So we sent a study to the FDA. We're waiting to hear back. We sent it in December, so we should hear by the end of January. And it's in our IRB, which we should hear by the end of February, for a donor study. And it will be 3 arms, 1 unrelated cord blood, 1 the MSC from cord tissue, which is unrelated, and 1 what we call natural history, where the children will not be treated for the first year, but they will get unrelated cord blood at the end of the year. And so that study is hopefully going to open in March. It's funded. We're just waiting for the regulatory approval.
Okay, and you think, I don't know what is the sample size, but you think it's big enough to have a chance to participate in it from Israel?
Yeah, the sample size is about 100 children. Yeah. So.